Welcome to WinDevCon 2007 Optimization course. In this course we're going to talk about several topics that are linked together about optimization. We're going to talk about hardware, we're going to talk about the use of profiler, and we're also going to talk about all the tricks that you can use in your software to optimize its function. The first thing that we have to understand is why do you want to optimize? The hardware is faster and faster every year. The networks are faster and faster. Even the web connection are faster and faster. Of course, during that time you also have Windows becoming slower and slower with each version. The application that you are building are more and more ambitious, and the user expectations are climbing. So when do you want to optimize? Of course, you should think about optimization all the time when you are coding. But we all live in the real world and, well, it's not working that way. So, basically you have two phases in your development cycle. First, the real development, make it work. And basically you add fat to your program. Then, well, you try to optimize and remove the fat, and then you start again. So you need to optimize when you see it's too slow, obviously. You need to optimize when your users are angry because it's too slow. And ideally you should optimize when you put your program in production. That's also what beta testing is for. You have a few customers in the real world trying your application. You work on it on your side, and at this point everything should be okay, should be working, and you should be able to optimize everything that needs to be. So, what are you going to optimize? Well, we already have these two different cases. If you already have a problem, obviously you're going to optimize the specific part that is slow. If your users are complaining about one specific part of your software, that's where you're going to look. Remember that it's not always the data access that is slow. In some cases I've seen processing of the data before display to be take more time than the data access itself. So you will have to identify exactly what is taking too much time and work on it. Sometimes it's not even always your program. It can be anything else outside of your program that creates the problem. So how to find out? Well, we're going to talk about that. Now, if you are trying not to have a problem, so if you are dealing with the optimization part before your application is in production, the first thing to do is to decide what the critical parts of your application are. You don't want to spend 2 years optimizing every line of code in your application. It's not worth it. You have to find out what is really important. And what is important is basically what is going to be used all the time. If you have 90% of your user spending 90% of the time in one module, you have to spend 90% of your time optimizing that module. That's what will be very important. So will that part be fast enough or slow? And you have some time to design your application around that particular problem. So what is time critical? Is it fast enough? If you have, by example, an application that has to be linked to any kind of specific hardware, and that hardware is sending information via, let's say, the serial port, and it's sending information on the fly like that with no control, not waiting for you or anything, obviously you will have to optimize that particular bit of code in order to always get the information coming in. You cannot afford not to get it. And of course also, what part will the boss see? Remember one thing, you have to keep the guy who is paying happy. So if is using only one small part of the program, like it's very often the case, and this particular part is extremely slow, by example, he's using the statistic to see what's going on in his company. Well, if it takes 3 days to compile all the information to provide a statistic, it's not going to be acceptable. 15 minutes? Yes, of course, you can do that because, well, it's statistic. But 3 days? No. So what will the boss see is also something that you have to work on. If we are in the case where you already have a problem, obviously you have to find the culprit. What is causing the problem? And the first thing that you want to eliminate before you start looking everywhere in your code is any type of external cause. So you're going to proceed by elimination most of the time, and you're going to try to find out if the problem is coming from a different hardware. You can absolutely have a problem coming from the fact that one particular machine is in bad shape, that is creating a problem on the network, and so on and so forth. So if you have the problem only at one customer on some specific machine, try to find out what is different and change it. If you go 10 times slower between one user and 2 users, well, that can be normal. Remember that if you have only one user, it's a very highly optimized thing. So 2 user is going to be the regular thing. Now it's perfectly possible also that this second user has a problem on his machine. So if it's only when you have 2 users but with one particular one all the time, then look at his connection to the network and all this kind of thing. Remember also that if your problem is only at the first time the files are accessed, it's perfectly possible that it's just Windows backupping the files. In Windows you have this system restore functionality, and for whatever reason the system restore functionality thinks that all NDX files are part of the system, which means that as soon as you start to access it the first time and you change anything in them, you just change the date, you do anything, well, Windows is going to back them up. If they're small, you don't see it, but if they are 2 or 3 gigabytes, it's going to take 30 seconds, 40 seconds, sometimes more. And the first time you open the application is going to be horribly slow. So to solve that, you just have to exclude these specific files from the list of files to backup in there, and for that you just change a particular key in the registry. This information is of course available on the different forums and I think in the FAQ of the PCSoft website. There can be any kind of other external problems that are the cause of your problem. By example, it could be an antivirus that is slowing down the process because it doesn't like the way your executable is built. I have seen some antivirus, and not to name, but it was in that particular case it was Norton antivirus, who would prevent one of my programs to run altogether. It would be totally blocked. I had to make the customer exclude my executable from the list of program to watch in order to make it work. That was the only way. For whatever reason, this version of the antivirus really didn't like my software, and I really was not doing anything special in it. Of course, it could also be that the machine on which you have this kind of problem is full of viruses that are using all the CPU. Always look at what the CPU is doing. The same exact way it could be any kind of anti-spyware program or spyware on the machine that is using all the resources, and because of that your program is much slower on that one. It can even be a screensaver. I have personally seen a case where well, reindexing the files would take between 20 and 30 minutes on this particular database and hardware. And well, the customer would call me and tell me, we've been doing the reindexation for the last 8 hours, we cannot work during that time and it's still not finished. And I couldn't understand why. And when I went over there and saw what was happening, it was just that on the server there was this beautiful screensaver doing these beautiful pipes going in all directions, and I'm sure you've all seen that one. A beautiful 3D screensaver, and this was just using 95% of the CPU time, which means that there was not enough remaining for the reindexation in the background, and the reindexation time was 10 times more. So just, yeah, people are putting this kind of screensaver on their server, so you have to check for that. It can be also in some cases the automatic indexation. Perhaps you've seen this feature that is available on every disk and partition in Windows, and it is turned on by default. What it does is indexing the content of every file in order to let the search in Windows go faster. Of course, to do that, it has to read the content of all the files all the time you're doing any kind of modification, which means that when you are modifying a 4 GB database and this thing is trying to index its content, which is of course encrypted, so there's absolutely no point in it, it can give some really bad results. So my advice would be to first uncheck this automatic indexation feature, and it will make the rare case when the user is looking for a file on the disk slower, but on the contrary, you will gain much more time. I've even seen a case where the automatic indexation would start on a machine at some point. It would start to process all the file, and if I had a big processing during that time, it would fully crash my program. So all this kind of automatic processing are something that you have to have a look at. And of course, yes, there's the wonderful case of the server being full of all the kids' game. Well, think about it. The boss kid is coming at the office after work, and well, you have to keep the guy occupied, otherwise you can't work. And there's only one computer with nobody working on it. It's the server. So what happened? Well, the kid's going to use the server and just use the card game on it. Yeah, except that he doesn't like the card game, so he's going to come with a CD with all his games on it, and he's going to install them on it, and he won't even ask permission to do it. It's normal, it's just a computer. And you end up with a computer with the C drive full, because of course he is not going to install anything on the D drive or E drive, he doesn't know what it is, so it's going to be on the C drive. The C drive is going to be full, so there will be no room for swapping. The registry is going to be totally full of garbage from all these hundreds of games that the kid installed at any point. And no, it's not fun. I've lived that, I've seen it. And it was not even possible to reindex the drive because it was at 99% full. The system was so slow that just to uninstall one game, it would take 20 minutes. It took me 3 full days to be back to a point where the system would work again normally. So this is real life experience. You can have huge problems like that, and it's not coming from your software at all. And of course all the other ones that I don't think about right now, but you will find them, I'm sure. Okay, now you've eliminated all the cases. It's doing the same thing in all cases. Okay, it's your program now. What do you do to find out what's going on? Well, the first thing that you have to do, of course, is to find out what part of the program is too slow. Obviously, you don't have a problem in each and every part of your software, at least I hope. You're not one of these guys building a database with absolutely no keys in it. Yes, I've seen that too. So, what part of the program is too slow? And to do that, one of the things you can do, of course, is to use the profiler to analyze what is too slow. The second thing that you can do, of course, is ask your users what is slow and what they are using all the time. But, of course, the profiler is a very good way to do that. We'll talk in detail about the profiler later, but let's just say at that point that it's something that you can set up in your program in order to have information, statistical information, come back to you from the user machine in executable mode. So it's an extremely powerful tool that you can use to find out what you have to optimize. If you are in the case, on the contrary, where you want to optimize before production time, now the first thing that you have to do is to identify what functions need to be optimized. You don't have a user to tell you this module is too slow. So remember, you have to find out the modules that are used all the time, the modules that are basically time critical, and what the boss is going to use. That's the three things that you have to look at, in that order, if possible. In each process that you identify, big processes like invoicing that you identify as being extremely important, use the profiler to identify the time needed by each part of the code. Use the module several times in all the functions that are going to be used. If it's the creation of invoice that is used all the time, then do that several times with different kind of invoices to check what's going on. If it's the printing of invoice that is important, then do that one and check all that. And remember the 90-10 rule. 90% of the processing time is in 10% of the code. You have to identify this 10% of the code and you have to optimize that code. That's where you're going to save a lot of time. Once you have identified this 10%, that's the focus. That's what you want. You don't want to spend any time on the remaining 90%. It's not important. That is where the time is spent. And always optimize from the biggest time spent to the lowest one. Remember, 5% gain on 80% of the processing is much better than 80% gain on 5% of the processing. You will have a much happier user base. We are now going to have a closer look at what kind of hardware optimization you can manage. First, the problem of network cables, switch and cards. Well, obviously you should prefer switches to hub. There are not a lot of network hubs still out there sold because the price of switches went down dramatically in the last few years. But still, what's the difference? Well, a hub is going to send every message that arrives to it to all the different lines of the network. A switch knows what IP address is on each line of the network. And because of that, he sends the message only to the line where this IP address is located. So obviously you have way less traffic sent through the switch to the remaining part of the network, and because of that, well, you have the possibility to have a much bigger bandwidth available for real useful network traffic. Also, you have the problem of the bad network card or switch. These two things can send badly formed frames on the whole network. These frames don't have a correct destination address. There's an error in the information, so they don't find their destination and they are just clog the network. One network card that is doing this kind of thing is enough to slow down tremendously a whole network, because these things have nowhere to go, they're just pinging back and forth. So that's clearly something that you have to deal with. Then of course there's the very good problem of the bad network cables. If we are talking about a category 5 network cable, it's very easy to put this kind of cable in place. It's a straight cable. The 1 goes to 1, 2 to 2, 3 to 3, and so on. There is nothing to it. That's why all the telephone company guys and the electrician guys are putting network cable in place for you. The only problem is that yes, it's a straight cable, but you're supposed to put specific pairs on specific pins, which means that you don't put any cable straight from one point to the next. And you have in something like that several pairs, and the first cable of one pair goes to the 1, the second goes to the 8, and so on, or to the 2, and then you have 2 of them that are to be this way and that way. There's a very specific schematic to follow. Most of the time when you are dealing with people who are not network specialists putting cable into place, they just read that it's a straight cable and they just plug any cable in any line. And the fact that these cables were designed to be really cabled one specific way to avoid self-noise is not their problem, it's yours. You end up with a 100 megabit network going slower than the 10 megabit network it was replacing. And you have to redo all the cables to solve the problem. You also have the case of the bad network cables because, well, they are partially broken, they are routed just near the luminescent lines, and so on. All that are causes for a network to be extremely slow, and if the network is slow, then your data access is slow. The tricky part is that the network can look slow with your application and not when they are copying one Word file from one machine to the next. Why? Well, because it's not the same work at all. When you are opening a table and routing data through that, you have much more data traffic that goes back and forth than when you're just copying a single file. So it looks like it's your application, but in fact it's the network. How do you find that? Obviously it's not easy. Well, one solution is to unplug the lines from the switch till the speed is normal. Then you replug them one by one, and as soon as the network goes bad, you know that this last line that you plugged in is the one where the problem is coming from. That's one solution. Another solution is to exchange hardware. If it's not the lines, it can come from that network cable or this network cable. So you exchange the cable, you just have one flying cable that you plug in exchange to another one, and you see if it solves the problem. If so, it's the cable. If not, then on that line it's perhaps the network card, or it can be the switch. And in that case you exchange the network card and you see if it works. If not, then it's the switch, and then you have to exchange the switch, and so on. So that's the replace one bad part with a good one. Of course you need to have the parts. Or you could call a real network specialist as soon as you find one, and this guy will come with the right network detectors and sniffers and all this kind of thing, and you let the guy do his job, find out what's going on, and solve the problem. Of course you need to find a real network specialist, but there are good ones out there, and 2 or 3 hours they will spend to put your whole network back in place is really worth the money. One aspect of hardware optimization that we all have a tendency to forget is the hard drive. Obviously, all the data access is done on the hard drive. So why don't we spend more time thinking about it and trying to have something that goes faster? You have to know that, of course, there are many different speeds available in the hard drive out there. different rotational speed, and of course also different cache size. So buy a faster one which has much cache as you can find, and don't just rely on the characteristic. Look at the tests that have been done out there by comparison, and find out which one is really faster in your case. If you are doing 99% of the time reads on the disk, you want a hard drive with as fast read system as you can. Now, if you're spending most of your time writing on the disk, that's the part that has to be extremely optimized. Sometimes one is extremely optimized and the other one is not so good. So check what you're doing and buy one that really will improve your data access. You can have a tremendous help from that system. The cache part is extremely important too, because, well, only the first time the data is accessed that you will have the hard drive really reading on the hardware itself. After that, that data is available in the cache. So if you have 1 megabyte of cache, or 8 or 16 or 1 gigabyte of cache available on the hard drive, obviously you have much more chance to have the data available the next time you want to read it. And in that case it would come directly from memory, so it will be 100 times faster than from the hard drive. So clearly you want to have something with as much cache as you can find. The next step is to look at the memory on your server. You have all seen at some point that the first time you access some data, let's say the list of company, it's slower than when you access it a second time. The reason for that is that data was loaded in memory, and because of that the disk cache system is loading it, reading it physically from the drive the first time, but then the second time it's in memory, so it's much faster, 10 times faster generally. So if you have this advantage with memory, an obvious solution is to increase the amount of memory to do that. We already talked about that on the hard drive system, where there is a cache, generally just a few megabytes of cache on the hard drive itself. But then you have Windows doing the exact same thing. There's a disk cache system in Windows, and that system is generally several hundred megabytes. It's part of the full memory of your system that is used for that. So if you increase the memory on your server, if you put 4 gig or 8 gig of memory on your server, if your server is able to manage that much, of course, then all this memory is going to be available for the disk cache, and you will have much more chance to have faster access. So just increase the memory on the file server. If you can also increase the speed of the memory on the file server, if you have the different speed available for that particular hardware, then of course it's another game. But the main thing is to increase the amount of memory on the file server. And then to continue on the same line of reasoning, if changing your hard drive and increasing the memory on the file server were not enough in your particular case, you also have the possibility to buy a specific software that is a hard drive cache. There are a few of them on the market, not a lot. They're not very easy to find because it's a very specialized system that not a lot of people need with current hardware. But there are a few hard drive cache software for Windows available. It's working in addition to the built-in hard drive cache. It's also in addition to the Windows caching system. So why are you going to add a hard drive cache software when you already have all that in your system? Well, you can set them up to have your whole database in memory all the time, which means that accessing your data is 100 times faster all the time. You have no control about the Windows cache system. Or the hard drive cache system. The hard drive is going to cache all the data that is accessed, being in your database or in anything else. Same thing for Windows. Anything that is accessed is cached in the system. Here you can set up yourself to have specifically your database in memory all the time. So they can do that for reading, writing, or both. So you can say, okay, I don't want them to manage the writing because I want the security of writing on the disk immediately, or I don't want them for the reading because what interests me is writing fast. But most of the time you want both of them to be as fast as possible. So you can set them up to work like a virtual mappable drive. Let's say that you have C and D physically in your machine. Suddenly you have E, which is, let's say, 4 gigabyte big only, and you have your 3 gigabyte database in it. And this will load automatically when you start your system. It will read the 3 gigabyte on the drive, physical drive, put them on the E drive, which is memory, and you will point your system to that memory drive. It will work exactly the same way that the drive works. So it means that your system will not know that it's not a physical drive. It will only know that it works 100 times faster than it should, which is really good. And of course you can set that up to have immediate writing on the disk or delayed writing if you want to optimize the writing too, which of course has the risk of losing data if you lose your system during that time. But if you just optimize the reading, all your queries are 100 times faster, and that's something that we all love. So at that point your first and second tries on a query are the same, because remember, it's when the system starts, it loads the whole database on the drive. It's a mappable drive and it's in memory all the time. Let's talk now about the graphic card. It's another element of your configuration that you generally don't think about. But would you believe that a graphic card can slow down your program? Most of the time when I ask that question, the answer that I get is no. Because, well, obviously I know that you are not programming video games. But when you are doing any kind of processing, like a loop on a file, and during that loop, because you don't want your user to think that the process is stuck somewhere, you are displaying something like the name of the company you are currently processing, which is something we all done at some point or another. You are in fact using the video card to do that display. And in some cases, I've seen process being extremely slowed down because the only video card that was in the machine was a very poor, slow video card integrated on the motherboard, extremely no processor dedicated to the video, so it was the main processor that was doing all the video calculation, and because of that the processor was not able to speed up the process that had to be sped up. So it's something that can and will influence the speed of your program in many cases. And believe it or not, you can have a process go 10 times faster because you have a good video card in the machine. This one is also hard to believe. AMD processor versus Intel processor. Am I trying to resuscitate the war of the processors? Well, yes and no. I'm talking about, again, a real case, something that I've seen in my life, and it was really hard to believe, and I've seen it. So let me tell you the story. I had a computer, it was a Dell computer, high-end Dell computer at the time, with a bi-processor Intel, not a dual core. 2 processor Intel on the motherboard with all the things that go with it. And it was a high-end machine, and I had that because I was doing integration of a big project, and the compiling of the project was taking 45 minutes on that machine. And I really thought that it was really too slow. And I had a bad feeling about that machine. So I asked for another machine to replace that one, or at least to have it on the side on that one and be able to do something during that time. And I got what I wanted, which was a machine with absolutely no brand on it, and only one processor, AMD, and the speed of that AMD was about 10% faster than each of the two Intel. So theoretically, the bi-processor Intel was supposed to still be 70–80% faster than my monoprocessor AMD. Well, when I used that new machine to compile the exact same project, the project compiling went from 45 minutes to 15, 3 times faster. And not only that, but that was just the compiling. Then the data access local on the machine was nearly twice as fast than it was on the bi-processor Intel. It was probably not just the processor. It was probably a combination of processor, BIOS, RAM, whatever you want. And I'm not saying that all the time AMD processor will be faster for what you're doing. That's absolutely not what I'm saying, because I had no way of testing that in all cases, of course. What I've seen, I think I've seen during the year, is that WinDev project seems to run faster on AMD processors. Is that because the code that is generated by WinDev is more optimized for AMD than it is for Intel? I don't know. I have no information about that. It's possible. It is just a fluke that I had on this particular occasion. It's possible. Mainly, my message on that particular point is that if you have a server that you find particularly slow, remember that perhaps by just exchanging that server with another one with basically what should be about the same power, you could have something that is much, much, much faster. And you will never know exactly why.
Hi, I'm Fabrice Harari, and we are going to talk about the WinDevCon 2007 Optimization Course Part 2. In this part, we're going to talk about the profiler tool and all the software trick that you can use to optimize your application. First, the profiler. The profiler is a tool built in WinDev, and one interesting thing that comes to mind immediately when you look at the profiler and the profiler help, you will find that in the profiler help it says a very important thing. If the process corresponds to a W language function, it is fairly hard to optimize it. That means that the profiler will let you analyze things, see what is slow. If the thing that is slow is your code, you can optimize it. If the thing that takes too much time is one call to a WinDev function, whatever that is, then you're dead in the water. You cannot do anything about it. It's their code, of course. That's in particular the case when you run a query. That's obviously working in their code, and the profiler will do absolutely nothing for you in that case. So the profiler is a built-in tool. It allows you to get processing statistic on your application, either on the whole program. In that case, you can just start it by going in project, profiler, analyze the performance. Or if you want to optimize part of your code, then you have to add in your code profiler start and profiler end commands at the beginning and the end of the process that you want to analyze. And this functionality makes it extremely interesting in that you can use it in your executable mode directly. It's not only in test mode, which means that you can put a profiler start, profiler end in your program somewhere, and have it run at your customer place. It also means that you can have, if you have critical parts in your application and you regularly have the need to see if everything is going correctly, if it's working fast enough and all that, you can leave that in your application and by example have it run or not depending on a value that you store in the INAF file or in the registry. So you can have optimization mode built in your program and available for you to see what's going on at your customers when they are saying it's too slow. With that you can tell them, okay, turn on the optimization, go there, this, or you do it yourself remotely, of course. Then you have them run their program absolutely normally, and at the end of that you will get a WPF file that you can work on at your office. By example, you can just transfer it and analyze it at your place. The WPF file is created in both cases if you are analyzing the whole file or using the profiler, start profiler, and the commands, and also if you're in test mode or if you are in executable mode. So in every case, each time you're doing an optimization analysis, you will have a WPF and you will be able to work on it now, later, compare the result from one to the other, and so on. Of course, if you do this kind of thing, if you use this functionality, it's going to slow down your app. It has to, because, well, it has to analyze what you're doing and write it in the WPF file. So it's just adding fat to your already existing fat. When do you want to use the profiler? Before production, as we said earlier in the part 1 of this course, and before beta testing. In general use, you want to try to see if anything pops up as really too slow and work on that. So that's a good idea to do that before you send the program to your customers. See if there's something that looks like it's really taking too much time in your program, and work on it. You'll have a much better answer to your software this way. Of course, during beta testing, you know what function your user are in most of the time, so you can add the profiler, start profiler, and commands in those functions, and get regularly the profiler files from your customers and analyze them and see if everything is okay or if there's something that looks strange. Again, when your user have a problem with the speed of your application, you can use that tool to see if it's really too slow or if they're just saying it's too slow because they have no idea what kind of processing is done during the program. So you can just leave your profiler start and profiler end in place with a switch that allows you to turn them on and off, and this way you'll say, okay, you're starting a query that needs to process 4 million records and do calculation on them, and you complain that it's taking only 7 minutes. Well, too bad, there's nothing we can do about that. Or you can see that a query that is supposed to return only 10 records is taking 35 minutes, and there's something that you should do about that. So how to use the profiler? Here's an example of the profiler screen. I just used an example in WinDev called WD Puzzle. It's a little game and has nothing to do with anything. Just to give you an example on how to use it, I used the general start of the profiler from the editor in test mode. And you can see that in the screen that is displayed at the end when you stop the program, you have 3 different tabs. on the summary tab, you have the 10 biggest time list. So that is of course is a good start, because, well, you can see what is going on. If you see that you have one function that is taking the most time, and it's not a function that is supposed to be that long, you can have a look in that. But it's not that useful, because at the same time it's going to tell you, okay, the main window of the application is taking the most time. Yeah, of course. It's where the user are spending the most of the time. So obviously you have to take that with a grain of salt. I really prefer the information that is available on the second tab, the Details tab. Here you have, of course, the list of functions, and you can sort by all these columns. Of course, the first column, very interesting, is the total time spent in the function by itself. You see, well, here's the whole program. I spent 5 seconds and 60 milliseconds in the program. In the main window there was 4 seconds. Okay, so this one obviously you don't care about. But after that, okay, when I clicked on this button, I spent more than 1 second in it. Is it normal? Is it not normal? It will give you an indication on where to look. Then you have the second column that is extremely interesting too. It's the number of calls of a procedure. So in that example, obviously there's nothing really popping up. But if in that column you see 3 million calls to that procedure, you either have a problem because you're calling a procedure that you don't need to call all the time, or you really need to call that procedure all the time for whatever reason, and in that case you really need to optimize it. So this between the total time and the number of calls, you have your two main tools to find where you have to look. Of course, here you have the choice to view or not each W language function total. By example, here you have the init random took 34 milliseconds. There's nothing you can do about that, because obviously you cannot change the code that is in the init random. But you could eventually remove some init random. You see there are 4 calls to init random. Perhaps you need only 1, and it means that you're going to save 3/4 of the time. You see, for each call you have here the average time for each call. So 4 by 8 is 32, and it took in a total 34 milliseconds. So you can play with these things even on the W language function in the way that you can see if a function is called and is not nearly really necessary. The init random is a good example, because generally you need 1 in your program. Why are there 4? Well, obviously I did several things that called it what, and you can look at that. Of course, if the only gain that you're going to get out of it is 20 milliseconds, that's not really the point. But if you had here 10,000 calls or 20,000 or 3 million calls, as I've seen in some programs, well, it's extremely important to have a close look. And then here you have a third tab with the calls on it. You can have a look. Personally, I really advise you to use these 2 columns as really your main tool. So let's see how to use it. The summary gives you the 10 biggest. That's a good start, as I told you. The detail tab is much more interesting. So we have seen all that. Look at the number of calls. It's really important. 2% of gain on 3 million calls is huge. And also, can you reduce the number of calls? Is it necessary to call that function 3 million times? And if you have too many calls to WinDev function, is it normal? Can you change it? So optimization is really a process that is done one step at a time. We're going to see what we can do. You will see first that you have to make choices, and we're going to talk about several important choices that you're going to make. Then, if you really want to optimize your software, you're going to need to really understand how the plumbing is done. How is it working below the surface? You're using a very high level language with WinDev. And because of that, many things that are done behind the scene, and you have probably no idea what they are doing. If you don't know what they are doing, you will have much more difficulty to optimize your code because you don't know what's implied in the function you're calling. So we're going here to see all the tricks that I could think of to tell you about what needs to be optimized, what you can look at, and what are the things you can do in your software. Let's see about the choices first. First, database to choose. For those of you who are not asleep during the data access course previously, we already talked about that, but let's talk about it on the optimization standpoint alone. If your application is used by one user only, Hyperfile is probably the best choice because it's going to be simple to manage and it's going to be normally fast enough to accommodate your need. Now, if your app needs to cover all the cases from one user to 5,000 users, Hyperfile can be used for small and medium ones. 50 plus user is manageable without any problem in a Hyperfile client server, by example. And for the big ones, really when you need 1,000 users, 55,000 users, you're going to have, in that case, a big database like Microsoft SQL or Oracle, and on a big server or server farms. Remember also that you don't have to choose at the beginning of your coding. The only thing that you should avoid at all costs is to code using specific SQL syntax. If you start to code using a specific SQL syntax, you're stuck with your specific database. Unfortunately, each big database on the market has its own little quirks, word that it's using and not using, or not using the same way. So either you're using Hyperfile syntax, which will work on all the databases that have native access, or you use standard SQL syntax. So if you don't have a really compelling reason to use another database, like by example you need 5,000 users on one system, remember that you have the automatic structure modification available in Hyperfile and Hyperfile only. So when you work on your program and you make improvement, it's going to be much easier on you if you use Hyperfile. And it doesn't matter which database you're going to choose. In every case, you're going to need to optimize it. So the keys are really the thing to think about. There are people out there working as database administrators. I know several of them. And what they're doing most of the time is look at the software written by somebody else and add the corresponding keys in their database, because the people writing the data access have no idea what to add as a key to optimize the access. So that's a big part of optimization, and you really need to know and understand that. So now you have the same question that we talked about before. Do you use SQL or HF? We're talking about syntax now because you know that you can use both SQL and HF syntax on both SQL and HF database, so it's really a question of syntax. Personally, I prefer the hyperfile syntax, HXXS, because you can go from HF Classic to Oracle with HF client server in the middle, MySQL, Microsoft SQL, all with the same H functions. Of course, you can still use queries when needed, but please stay clear of any syntax not supported by all your potential databases. Really, don't fall in the trap of using specific syntax for Oracle. You're going to be stuck with Oracle and pay for Oracle for the whole life of your program. And perhaps you don't need to. Of course, some of you will disagree. One of the very good thing in WinDev is that you have many ways to do the same thing. I prefer some of them. Some of you will prefer other for a lot of very good reason, and I'm not going to argue about it. You have some compelling arguments, but at the same time it's a choice and it's a way of working. So you have to be comfortable with your choice. So some people are going to tell you that using SQL syntax is much better than HF because only the desired fields are returned. So it's true if you don't need the whole record. Of course, if you need the whole record, everything is coming back. It's true, yes, only the fields that you are selecting in your query are returned. But you will get all the records matching your condition, and you're going to wait for them. With H commands, you can read only the beginning of a subset and work only on that. So it's really a different use. You can definitely have gain using both syntaxes. And remember also that it's true only the fields that you select are returned, but that's true only for the transport, for the network traffic. The data file access is the same. The SQL engine still needs to read physically the whole record in order to extract from it the fields it's going to return. So you still have the data access on the server that is the same. Also, you can do the same thing without using SQL, using H syntax views with the fetch argument and even stored procedure. So the argument that okay, just the desired field return is true, but for me it's not a compelling argument. So in my opinion, there is no definite advantage to one side or the other, except perhaps for two things. The first one is the debug capabilities that we talked about in the data access course. You can debug step by step of your data access with the H syntax. You cannot do that in a SQL query. Then an even more important thing is that with HF Classic or client-server databases, you have this automatic structure modification tool available, and it's a great tool. It's working really well, and well, if you don't have it, you are back to changing the structure by hand, by code, and doing the little loop in your code to initialize the new fields and all these wonderful things that I'm trying to avoid as much as I can. We are now going to try to understand some of the plumbing regarding the keys that you have in any type of database. And for that, we're going to talk about binary trees. It is a geek moment, so those of you who are afraid of that, please settle down. It's going to be painful for you. By example, keys that are traditionally organized as binary trees are going to be managed the following way. This is the data that we're going to try to arrange as key would be arranged. It's the first name of members of my family. And this data this set of data, as you can see here, it's sorted in alphabetical order, can be organized the following way. I'm sure you love that. So, how do you organize this kind of data, a list of first name, in a representation like that? Well, this is organized in the order in which the data is added to the file. In that case, the first record that was added is Laura, and then the second one could be, by example, Fabrice, or this one. It doesn't matter. If after you already have Laura, you want to add Fabrice, what is the rule? The rule is if the alphabetical order of the second one is less than the first one, then it goes on the left side of the tree. If it's equal or greater, that's the difference between key with duplicate or a unique key. So if it's equal or greater, it goes on the right side. Okay? So if we add Fabrice after Laura, obviously it goes on the left side. There's nothing already in the trees on that position, so we can store Fabrice here. Let's say that after that we have Agnès. Agnès is before Laura in alphabetical order, so it goes on the left side. Before Fabrice in alphabetical order, so it goes on the left side. There's nothing there, so we can put it at that position. Then we have Henry. Henry is before Laura, left. After Fabrice, right. Nothing in that position. We put it there. Then we have René. René is after Laura in alphabetical order. It goes on the right. Nothing there. We can store it. And then we have Sonia, that is after Laura, after René, and therefore goes there. And here we have an empty spot ready to accept any value that would match these very simple rules. That's how a binary tree is organized. And of course, you can manage this kind of thing in memory anytime you want. But that's the way the index file in a database is generally organized. Now, let's have a look at this one. If you have a close look, you will see that, if I didn't make any mistake, you have the exact same data than in this one, represented in a slightly different way. The only difference between these two things is the order in which the records were added. In this case, the first record that was added is René, then Agnès and Sonia, then Fabrice. And you can see that here, because of the order in which it was added, we don't have 3 levels, we have 1, 2, 3, 4, 5 levels. And it's the same data. But it means that if we want to access all the record of this tree, we'll need to go through 5 different levels, which means that it's going to be slower than here, where we have only 3 levels to manage. The difference in that is just the order in which the records were added to the file. So why do you need to know about the organization of keys and binary trees? Well, the first reason is that if you want to have a fast access to data, it will have to be via keys. And if you understand how the keys are working, you will understand better how to design composite keys, how to design queries and conditions. Let's have a look. If you want to find the record Fabrice, if you don't have any key, you will have to go through the whole file, check each record one after the other to find the one or the ones that match your condition. Now, if you have an index key on the first name, you will just have to request it. How will the system work? Well, it will read a part of the index file, one block of data. It always works via blocks. And in that block it will look, okay, the first one that I have, the root of my tree is René. I'm looking for Fabrice. Is that bigger or before or after? It's before, so I'm looking on the left side. I have Agnès. Is it before or after? It's after. I have Fabrice found. In reading one block of the index file and going through 3 very simple tests in memory, so extremely fast tests, I have my record. And of course, I don't only have only the first name, I also have the address of the record itself in the data file, which means that I read one block in the index, made 3 fast tests in memory, and I access my record in the file. That's how it works. As you can see, it's extremely fast. Of course, it could be that the index file itself is extremely big, so you don't find the answer in the first block, so you read the second block and the third one and the fourth one. But still, it's going to be way faster than reading all the records. The second reason why you have to understand how this works is because this is the explanation of what the reindexation does. You remember on the previous slide we had the exact same data presented on 2 different ways, one with 3 levels, one with 5 levels. Obviously, if you have the data, the same data as 5 levels instead of 3, and you have to find a record that happens to be on the last level, you have to do 5 tests, 5 comparison instead of maximum 3 in the first case. Which means that statistically the second representation I gave you is slower than the first one. And the reindexation is just recreating something that looks like the first one, that is more compact. That's also what this value that you can set up in the reindexation system is. This filling value that is 80% by default. That means is that there are 20% of the slots that are left empty in order for you to be able to add data more easily without having to create a new block to link to. So when you're giving 80% as the value for the reindexation, it means that you have something that will be fast for reading and let you be not too slow when writing. When you are asking for 100%, it will be faster for reading, but of course slower for writing, because there will be no empty slot like this one to put a value that would have to be between Agnès and Fabrice, which means that you will have to, if you want to add a value, to go further away and create a new block. It also explains the difference between data access with or without key. Again, if you don't have this kind of key and you want to look for Fabrice, you have to look through all the file, the whole file. That is the explanation. And finally, it explained also why I insist so much on the contains condition. It's very easy. You can see here that you can find information that is before or after this information, but you don't have anything for contains. In more detail, let's have a look why you should never use contains in a condition. Let's try to find a way to access all the records containing RI. Okay, so we're going to use the same method that we used for finding the record Fabrice. Is the first one containing RI? No. Is RI before or after René? It's neither before nor after. So it means that first you have to check the left side, then the right side. So is it in Agnès? No. Is it in Sonia? No. Next level. Is it in Fabrice? Well, isn't that one is empty? Fabrice, RI? Yes. This one is an answer. So does that mean that I'm done searching? No. Could it be after or before Fabrice? Yes. So I still have to check that one. This one is an answer too. That one is an answer too. And I still have to check that one. Which means that this tree doesn't give me any solution to find the record except going through all of them the exact same way as I would go through all the records without any key. So that's the problem with a condition like contain. And there is really no solution for that. So except of course if you start to build a dictionary, and in that dictionary you store all the things that could be looked upon in any words. So if you allow your user to look for 2 letters in anything, not full words, it means that you will have to create a dictionary, and in that case it will contain RE, then EN, then N, E accented, and then here it will contain A, G, then GN, then N, E accented, then ES, and so on and so forth. And if you accept also that it's searched for all 3 letters, you will have to create a dictionary with the 3 letters word in it. So as you can see, it can be extremely costly in terms of disk space, and also in terms of time when you are writing a record. So most of the time when you are building a dictionary, you stop at the level of words. And if somebody wants to find anything that contains RE, they're on their own. You have the same problem with another condition like ends with. You have no way of finding that directly here. Of course, there is a trick for end with that is very easy. Each time you want to write a record and you want to be able to search on end with on something, you create a second field in which you store the same string starting with the end till the beginning. You just invert the string. When you do that, you suddenly have a field that you can put a key on and where you can find something with ends with. But of course, it will double the space in your database if you need to do that. So, as you can see, all the conditions that are not optimized at the beginning are going to create for you added load in order for them to be usable in any kind of fast way. Another consequence of that organization is that each time you're putting an OR in a query, you are in fact running 2 different queries. So a query with 5 ORs, or even better, a query like get all record where a value is in a list of value, which means is this value or that value or this value or this value, will just multiply the time needed to find the records. Either each part of the query, each condition of the OR is going to be a separate data access on a key, or if it's a little more optimized, you will read all the record of the file and test. So OR is not your friend. Each time you're doing an OR, in fact, you are adding the result of 2 queries. Now that you understand this binary tree organization, you should be able to directly see why a condition on a field that is not a key is not an optimized condition. You don't have this binary tree to access the data, so each time you set up a condition on a field that is not a key, all the records have to be tested, one after the other. Which is, of course, is acceptable only if you already have reduced the dataset by previous optimized condition. So yes, if you do a condition where you have date equal precise date and field that is not a key equal or contains even this or that, well, if you have only 10 records that match the date in question, it will be very fast because this will reduce the dataset and the slow test will be done only on 10 records. Now, if you have 20 million records matching that particular date, it will be an extremely painful process. And it, of course, is the same thing for a condition like contains and with, because for those, the binary tree has absolutely no use to help for fast access, so you have for those conditions to go through all the records. And even for good condition in a barred order, remember the composite key funnel theory, all good conditions should be on the first part of the composite key. If they are not, it means that first you will have the bad condition applied on the file, and then the good condition on the remaining thing. It's absolutely not optimized. Therefore, the answer for fast data access is to create the right keys. I probably already told you that 10 times. So create the right keys that will make 11. That's the important thing if you want to have a fast data access. If you are using queries, WinDev will tell you which one. In that case, you will have in the analysis this kind of thing. This is a query, and this query is composed of two conditions. City starts with L and customer type is equal to employee pipeline. That's the condition. And then you see this small thing in the upper right corner of the analysis screen. And this is a chronometer with a red part in it. It's the assistant, and when you click on it, you get that window and tells you that the query has been checked and you should make modification in the analysis in order to get the best performance for this query. And it tells you to create a composite key composed of customer type and city in the customer file. And you can see that the first part of the composite key is the second condition, and the reason for that is that it's an equal to condition. The second one, city, is starts with. Equal to is stricter than starts with. Therefore, the composite key first field is customer type. It exactly matches what I was telling you about this funnel theory. Now, if you are using HF syntaxes, you will have to think yourself and create those keys by hand. The WinDev system will not be able to tell you how to optimize the database. In all cases, whether you are using HF syntax or queries, if you are using hyperfile database, calculate the file statistic regularly. It will help the engine make better decision about which key to use for this or that query. Or even if you do a H filter with a condition, it will also choose the right key in a better way. And then we arrive at the jigsaw problem. Imagine, what do you think is faster? This or that? If you had to run from here to here, and you had the choice between this path or that one, what would you think would be faster? I hope that you are all going to answer the left one. That's what happens in data access when you are not optimizing the way you are accessing the files. Let's take an example. You have to deal with companies and the related contacts. Again, we go back to that simple example. If for you loop on companies and for each companies you are reading the contacts, you are in fact doing the right thing. Here you're reading a company, you're going on the hard drive to read the several contacts linked to that company. Then you're coming back to the company file that is another place on the hard drive, reading another company, then back to the contact file, reading several contacts, back to the company, and so on. If you're using an optimized processing, what you're doing is reading all the company and storing them in memory. Then once it's done, you start to loop on your memory and you read all the contacts. That's very simple. And it is extremely faster. So if you're doing your data access in a hyperfile, you can choose whether to code it this way or that way. In SQL, you just don't know, if you're using a query, how it's going to be physically read on the hard drive. I really hope that the data engine are optimized enough to use the optimized data access, but I don't know about that. I have no information about that, I just don't know. We're now going to try to explain another part of the plumbing that you are all using without ever thinking about it. It's called malloc. And malloc stands for memory allocation. When you are doing anything in a program that requires variable, you are allocating memory. In fact, your program is saying my string is string, and automatically WinDev behind the scene is reserving some memory in order to be able to store that string somewhere. Same thing for integers, something for anything like that. So each time you are creating variables, you are reserving, in fact, a part of the memory. And memory allocation takes time. Imagine you are declaring variable being regular variable or object. Each time WinDev is going to ask the system for room to store that information, because it doesn't have all the memory available to it. It needs to ask Windows to give me some more memory. That's why the occupation of your program, if you look at it in the system, increase over time, because you are asking for more and more memory to store your variables. Well, of course, Windows has to look where there's memory available, store in its information table that this memory is for that program, then answer your program, and all that takes processing cycles. It takes time. So, of course, all this is extremely fast, but still, each time you declare a dynamic object, each time you change the dimension of a dynamic array, in general add object like table, list, element in memory, each time you open a window where there are local variables, all that add to the request for memory, and all that takes time. So obviously, if you declare 4 million objects, it's going to take 4 million times the time to reserve the corresponding memory. So it's not a good idea. It can take really a lot of time if in the loop you are doing this kind of thing. The same way, it's not a good idea to manage dynamic array and add records in dynamic array one by one. For those of you who are not using dynamic arrays, here's how it works. You create an array saying it's dynamic, and you say at the beginning there's no line, its size is 0. Then you need to add a line, so you dimension the array with one line more, and you put your value in it. That's basic thing. The problem is that if you do that 1 million times, each time you're asking Windows to give you some memory. Now, if instead of that you create your dynamic array with 100 empty lines, you're going to add 100 value in it before you ask for memory again. And once the 100 lines are used, then you're going to ask for 100 more. You will have a few lines that will be empty at any time, so you will use a little more memory than you need, but the speed at which you'll be able to store information in your array is going to be much, much, much greater than it would be if you allocate it line by line. So when I saw a post in a forum complaining about the time needed for an application to create the object it needed, it was really funny for me because it was creating 2000 objects. That's not that many, but each of those objects would create 2000 more objects inside it. That's 4 million objects. And each time you create an object, remember that you have to reserve a memory zone matching the size of all the variables declared in the class. You have to allocate a pointer to that zone. You have to execute also the code of the constructor, which takes time depending on what you have in it, or at least call it to see if there's something to do. And you do that 4 million times. Yes, it's going to take a few seconds, perhaps a few minutes, depending on what you're doing in your constructor. Should you be surprised about that? No, it's normal. So perhaps try another way. Perhaps create only your 2000 object and in each an array of 2000 string. That would be enough. Because if you persist in that direction to create 4 million objects because you need 4 million objects, well, I don't know what kind of program you're writing, but I'm guessing it's not going to be fast at any given time. Just way too many things to manage.
When talking about optimization, multitask is also a very important subject. You may already use it, or perhaps you've never heard of it, but you have to know that multitask and multitask redraw are two W language instructions that can be used to allow for UI display while in a long process loop on reading or modifying records, by example. How does that work? Well, remember that Windows is working as a loop with message. That's the important thing to remember. So when you are in the process of looping through records and modifying them by example, and you want to display something, well, in that case you're going by example to put the name of the record, the name of the company record that you are processing in a static field in your window. And because you just put that value in there, you would think that it would appear normally on the screen. Only while you are processing your record, the processor is busy doing that. And it means that the message telling Windows that there is new information in that window and it has to be redisplayed is there in the stack, but not processed by Windows till Windows can do it. And as Windows is a cooperative multitasking, it won't process it till you give the control back to Windows to do so. That's what multitask and multitask redraw are doing. The difference between the two is that multitask redraw only allow Windows to redraw one particular window, while multitask allow Windows to process basically everything that was waiting for it. So clearly both of those instructions are going to take time. Windows will need time to refresh the window or to refresh the window and do everything else. In theory, multitask can take 10 times more than multitask redraw because, well, obviously, if there are many more things to do than just refresh one window, it will take the time to do all that. On another hand, multitask allows for something that multitask redraw don't, and it allows for the user to interrupt your process, if you code for it, of course. How does that work? Well, remember that if you want your user to interrupt the process, the user will have to do something for that. It will have to click on a button, to press the escape key, do something like that. And all that will end up again as message in the huge Windows stack. Well, if you don't use a multitask to let Windows process this message, they won't be processed till the end of your own code, which means that, okay, the user pressed the escape key, but nobody knows about it. Windows didn't manage it. So when you do a multitask, you let Windows process that escape key, and therefore you can test for the escape key in your code, or check if a flag has been reset, because that's the code of the button that the user pressed to cancel the process. So that's the difference between multitask and multitask redraw. So if you need that kind of functionality, if you need to display information and eventually let the user interrupt the process, well, my advice is to use multitask redraw to do the display of information, and from time to time, once every 10 multitask redraw by example, add a multitask in order to manage a possible interruption. So the interruption will be possible only every 5 seconds or so, but that's acceptable. This way you won't lose too much time by just doing that. Another thing that you can do, of course, is when you do multitask redraw, don't do it for each and every record. On current machine you can process several records and sometimes several tenths of record in every second. Sometimes even more if you have an extremely fast system. So you don't want to display each and every one of them. Nobody will be able to read them anyway. So just do a multitask redraw and set the value in the static field every 10 record or 20 record, or just every second. Store the last time and set a value each time the duration has increased by 1 second or 5 seconds, whatever you need. This way you will lose really way less time than by displaying each and every time. And then there's also something else that you have to consider. Multitask and multitask redraw are also ways to unoptimize your application. Yes, I know that we are in the optimization course, but unoptimizing an application is also something that you have to think about. By example, you are currently coding something that is kind of a background task, calculating statistics, by example. And you do not want to stop the whole machine during this time. Imagine you've coded something like a connection to the company phone system, and each time the phone rings, your system automatically look at the phone number coming in, and if it's the phone number of a customer, display the customer form on the screen immediately. Well, what happens if your statistical calculation use 100% of the CPU all the time? Obviously, this process cannot happen, and if it cannot happen, the coding that you're doing on one side is going to kill the coding that you did on another one. There's also another point to consider. Even if you didn't code something that needs to be able to run at any time, nothing tells you that the user is not using any kind of system like that on his computer at the same time. By example, I'm using Skype for my communication need, which means that when somebody calls me, my computer rings and I'm taking the communication on my computer. If my processor is fully occupied by any task that I'm coding, apart from the fact that it's going to make my laptop processor overheat and my laptop stop, but even if that wasn't the case, if I don't have enough processing power left to get my communication, then I cannot use this communication system on the same computer that I'm using the program you're coding. And I don't like that. I want to be able to do both at the same time. So by using multitask or multitask redraw in your application, and multitask mainly, you can choose not to use too much processing. And in fact, you can let the user select a value, 10, 20, 100, whatever, in hundreds of seconds, that the multitask is going to do from time to time to let the processing power available for something else. So you can have, in fact, a setting in your parameter to let the user do exactly that. Another optimization trick concerns dynamic arrays and structures. When you are using this kind of thing, always remember to allocate by chunks. How do you do that? You use the dimension instruction in the W language to say, okay, my array is a dynamic array of string, by example, and the dimension of my array is 100 lines. So you can put 100 string in this array without doing anything else. Then you keep in memory the maximum value used. First time you keep a counter, and each time you add a new string in your array, you increase the counter. And when the 100 lines are used, then you dimension again your array to a new size. And to do that, you do dimension my array, max value used plus 100. By doing that, you will get a few empty spots all the time at the end of your array, which is clearly not really important considering the size of the memory available now on today's computer. But instead of doing a malloc each time you are putting a new line in your array, you're doing one malloc, bigger one, but it takes the same amount of time, every 100 addition in your array. And it means that the time used for the malloc is 1% of what it would be otherwise, and it becomes negligible. Denormalizing is another way of optimizing your software. What do I mean by denormalizing? Well, we're going to start by a few examples, and you'll see more in detail what I mean. The first thing that you have to realize is that it is counterintuitive, but coding well means coding slow. And that's something that many people have a lot of trouble understanding. The best example for that is recursivity. Recursivity, if you never heard of it, I doubt it, but if you don't know what it is exactly, is basically creating a code, a procedure by example, and this procedure is calling itself, and in this again calling itself and calling itself and calling itself, and in each call of the procedure it's going to process one element, then calling itself to process the next one. That's the way it is done. Of course, remember that recursivity is not supported in WinDev, because the maximum amount of calls that you can put one after the other is in the current version 11 600. It was way less in with FI5, if I remember correctly. It was 113, now it's 600, but it's still officially recursivity is not supported. But that's something that you have to learn when you're in school, when you're learning software, and they are telling you that it's a very efficient way of doing things because, well, you have a very short code. There's only one problem. It's the worst possible method of coding for speed. Why? Imagine that. Your code is extremely short. Sometimes you have only 2 or 3 lines inside your method. So the execution time of that code is very short. But each time you're going to the next element, the next step of your loop, well, you are calling another procedure. And when you call another procedure, the processor has to save all his registry values, all the addresses, all the things that he was currently doing, then jump to the next procedure, do it, and once it's finished, restore everything. And this saving, restoring, and calling is sometimes longer than the execution of the code that you have inside the loop, which means that by coding it that way, you have multiplied the length of your code by 2, 3, or 4, perhaps even more. So when you have more time spent in calls management than in your code, there's a problem. And remember, each time you code something in using recursivity, you can code the same thing in a regular loop. It's generally way easier to code because it's way easier to understand. It's also easier to maintain and debug, and it is much faster. So yeah, it's wonderful to be able to code a whole process in 3 lines. But first you're going to spend a lot of time to code it to make it work, and then another lot of time to debug it and maintain it and modify it later. And worse, it's going to be 3 or 4 times slower than if you would code in a regular loop. So that's one example. Now there is an even worse example. Reusability of code is something that we all thrive for. We do not want to code twice or 3 times the same thing. So each time there is some code that is reused somewhere else, you put that in a procedure or a method of a class, and then you call it from wherever you need. But then you end up with lots of procedure and method, and some of these procedure and method are extremely short. The code is short, optimized, very fast. You have the same problem that you have in recursivity. Now the calls to this method take more time than the code itself. So if you remove it from there, from that procedure, and copy it in your calling code, you gain all the calling time, sometimes as much or more than the code time itself. And that's ugly. I'm not saying that you should do something like that. I'm just saying that in order to gain enough time in some process, I had to do this. It was the only optimization left for me to gain enough time. So if you have to do that for optimization, my advice would be to leave the original procedure intact, leave it there, just don't code it. Copy its content everywhere you need, and before and after this content, put a comment very easy to find, always the same, very easy to find with find and replace, in order to be able to identify that this following code is in fact a duplication of the procedure this and that. Why? Well, because at some point you will have to modify that code, and you will want to modify it everywhere it's used. And also you will have to debug this code, and if you correct something in it, you will want to be able to find easily all the places where you don't call but now reuse the same code. So that is clearly ugly, but that's sometimes the only way to do that. Here are a few more examples of denormalization that you can use to speed up the process you're using in your software. The first thing you can do is to increase the complexity of your code to save time. An example of that: you are calling very frequently a method in one of your classes, by example, and in this method you are sending back a value coming from a dynamic array in your class. Okay? So that dynamic array can be several hundreds lines long, and you are in fact looking for values in this regularly. It just happened that very often when you're in a process, you are asking for the same value. You are regularly asking for values that are different, of course, but when you do so, you are asking statistically for the same one very often, perhaps 2, 3, 4, 5 times in a row you're going to ask for the same one before asking for another one. And if you're in a case like that, one thing that you can do is, in this method that you are calling, you are going to use 2 local variables, well, local to the class of course, in which you're going to store the last question that was asked, what was asked in that method, and the last answer. And the first thing you're going to do in your method is to test is the calling code asking me for the same thing than last time? If yes, return the same answer. Why? You are adding code now in your method, so it's going to slow down every call to that method. Well, yes, it's true. It's going to slow down each and every code of this method. But for every time where you're going to be in that specific case, it's going to save much more time than the accumulation of lost time in the other case. If you have to search for a value in a dynamic array that is several hundred lines long, it means that you're going to have to loop through that array. And that takes a lot of time if statistically the value can be anywhere in the array, so it will take from 1 to 300 loops to find the answer. Statistically, it means it's going to take 150 loops. So if your test at the beginning for the last value and adding that value at the end at the return call takes less time than 150 loops in the array, it means that statistically it saves time. It's strange, but it works. Of course, it means that at some point some process will be perhaps a little slowed down, but statistically on the life of your program you will gain time. Then another thing that you can do, if you read parameters from disk, I'm talking about the case of a highly customized application with user preference everywhere, by example an application where all the columns that are displayed in the table are defined or definable by the user, so there's nothing hard-coded in your program. Basically you are just saying, okay, it's that this column, that column, this column, that column, and so on, and you define that and you display it. In that case, you're going to need to read lots of parameters from the disk all the time. And this, of course, takes time. So in order to speed things up, the first time you read this parameter, any parameter, you read them from disk. Then you store them in any kind of structure in memory, objects, arrays, dynamic arrays, and so on. And the next time you need the same value, you look in the array, which is going to be much faster than looking on the disk. By doing that, you are complexifying your code, and you are slowing down each read on disk because you also have to copy the value in an array. But statistically, again, you're going to gain a lot of time because the more time passed, the more parameters are already in memory and you don't have to read them from disk, which is much slower. There is a downside to that, of course, is any kind of outside process is able to modify these parameters, like a replication process, by example, or like the the admin of your network modifying the way some table should be displayed. Well, because you're not reading this parameter from the disk all the time, during some time you will continue to use the old parameters that are coming from your memory. It's only next time you choose to read from disk, which can be only next time you start the program, or every hour or so you reset everything and you restart, whatever you need. But till then you will still use the old parameters. So if it's okay in the case of your application to have this kind of behavior, then that's another way to speed up things. Another thing that you have to look at when you are working on optimization is your loops. Your loops are the places where you are taking a lot of time to do things. Because, well, you obviously, if you have a loop, it means that you're going to run through it perhaps a few hundred or a few thousand times, sometimes more than that. So everything that is inside the loop is extremely important. You should remove everything that you can from them. So if you have to call a WinDev function or one of yours, well, look closely. Can you call it before the loop? and store the value in a variable and use that value from the variable inside the loop? Because if the result of that function doesn't change during the life of your loop, then it's much faster to store the value and use it from the storing variable than to call the method each time. Well, at least it's supposed to be faster. We'll see about that later. It is written in the help. Local variables are faster than global ones. So the helps tell you if you want to go faster, copy your global values in local variables and then use them in your loops. So if you have a procedure using some of its parameters in a loop, these parameters at that point are coming from somewhere else. So they are as slow as global variable. So instead of doing that, copy their value in a local variable and use it instead. There are other reasons why you should do that, but that's more part of the good development practices than optimization. So remember, local variables, it's written in the help. That's once again written in the help. Do not do myString with a variable name in between these wonderful brackets. Use instead this syntax, in variable. Why? Well, again, it's about the plumbing. How is indirections managed in WinDev? Obviously, when you're doing that, when you're asking the compiler to work on a string that contains the name of an object, at some point, and it's execution time, the WinDev DLLs, the virtual machine, will have to replace your string by the real variable. And for that, it will have to find where this variable is. Remember, inside binary code, there's no name anymore. We are talking about a memory address. So it will have to find that memory address. And in order to do that, it will have to go through the whole set of arrays of variable fields, window control, windows, files, and so on and so forth to find the corresponding name. If you use the second syntax saying in variable, it means look only in the array of the memory variable. Don't look in the list of files, don't look in the list of windows, don't look in the list of reports, in the list of fields for each file, and so on. Just in the variables. And of course, this will be only a few percentage of the whole thing. So each time it's going to be much faster. Remember also that you should never use indirection inside the loop. Remember what they have to do. Each time you use an indirection, it needs to go through all these list of objects to find the correct address. Well, even if you use the second syntax and it goes only through the list of variables, it's still a loop. So if inside your loop you have this added loop done each time, it's going to take time again. So instead, do that outside of the loop and copy the content in the local variable and use that one. It's going to be much faster again. When you talk optimization, animations are your enemy. You can add an animated image in a window, but added to the fact that it will give a headache to anybody using that window after just a few minutes, it will also take up to 100% of the CPU power available just to process that animated image. So just forget about it. It's not a good idea. It's a little thing that is available that you should never use. You also have to remember that all objects are not equal. In this example, I'm talking about memory zone versus array. Well, I had to code some processing at some point where I found out that memory zones were much faster for my need. The more precise example, I tried to implement several sorts of things, and for several kind of sorts for a dynamic array, different algorithm. And then I simply copied its content in the memory zone, sorted by the sort mechanism of the memory zone, and copied back. It was 10 times faster. That's not even something that I did personally. It's something that a friend of mine did at the time, and when I saw the result, I couldn't believe it. So I tried myself and found out that yes, that was true. So does that mean that you should never use an array and all time use memory zone? Not at all. That was several years back, and you just don't know how they are coding things today. Remember, there is no guide. Nothing tells you that this object is going to be faster than that one for this kind of processing or that kind of processing. You are, according to PCSoft, using a L5G. You don't know what piece of code is doing behind the scene. The only purpose of that slide is to tell you test different options. All objects are not equal. You can do the same thing using many different objects, and sometimes you will get something that is much faster. So think about that when you need to optimize a process. And then sometimes you have to make a choice, optimization or functionality. We have the example of the log. At some point we are going to talk about debug. And in order to debug in some case, I'm going to explain how to log in a file, write information in the file as the program runs. Well, obviously that is taking time. Logging is going to slow down your application, and in some cases it's going to slow down your application a lot. Imagine that you have a loop processing things in memory, no file access at all, and inside that loop you log what you're doing. Then suddenly your memory process becomes a hard drive process. So it can slow down your application a lot. Obviously, you need to log to debug, but you don't need it all the time. So you're not going to leave your log lines active all the time for your application. But if it's a complex application and you know that you will have many modifications in the application as times pass, perhaps you will want to leave the line in the code, but just make them run on the result of a test. If a flag is set, then log. If you do that, you don't log when you don't need it. And if you need to see what's going on, you can just turn on a value in an INF file, by example, and you start logging. So that's a good way of doing things that doesn't slow you down, at least not a lot. And you still have the functionality. But then, sometimes it's just not enough. Why? Well, you can set it up as optional, but you're still going through all these lines of test. If you log a lot in your application, and I have an example of this huge application I was working on, extremely complex, where we needed to have a really full log available regularly to find out what was going on. So in every method, every procedure, every snippet of code, we had logs. And these logs were on or off based on a flag, exactly the way I told you. Only the problem is that the application was still too slow coded like that. So I tried, and I had good result. I tried to comment the lines. All the lines were starting the same way. If my flag equal true, then log. Okay. So what I did was replace all the if my flag equal true, then log by / if my file equal true, then log. And that alone made my application go 10% faster. There were so many calls to that log, so many tests done in the application. It was in every small basic procedure or method that was called millions of times, that it was taking up to 10% of the time in the application. That's huge, and that's really crazy. But that was the level of debug that we needed for an application that was so complex. So what can you do in a case like that? Well, you can comment all of them and just have your regular application like that. And if you have a problem somewhere, you just recompile your application after removing the / everywhere by a full replace in your project, and send the customer a debug version with 10% slower but able to log. Another thing that you can do is check out which method are called millions of times, and in this method remove the log. If you know that this method have nothing to do with anything else, they're just, let's say, converting the format of a date, and this is working, so this is not the cause of any problem, anything. You're sure enough of that specific code that you don't need to log it anymore. Are you saying, okay, I'm going to remove these lines from all these methods that are extremely heavily called? And this way you're going to gain time also. You're going to lose functionality in order to optimize your process. And remember not to forget the obvious. If suddenly the program is slow, if it was working fine and from day 1 to day 2 the program becomes slow, there's something else going on than just one line of code somewhere. So what can that be? Remember all these things that can be wrong. It's the obvious. The disk is full, the performance is down, just as stupid as that. Remove the kids games. That's very stupid case of optimization. Reindex your files. Sometimes you just forget to reindex your file. Remember also that the disk has to be defragmented. I've seen in some cases people not defragmenting the drive for years. And I've seen cases where defragmenting the drive took 3 days, 3 full days. It was so fragmented that it was taking forever. So remember that it can make a huge difference. Defragment the drive is on the list. And also remember that if you just added a new functionality, the log by example, and suddenly the process is slow, well, perhaps it's just because, well, the log is on and, well, it shouldn't be. It can be as stupid as that. Oh, my program is so slow. Okay, did you stop the log after sending me the log file last time? Oh, no, I don't think so. How do you do that? And suddenly you have an extremely slow program. Now you know all the tricks, at least all the tricks that I know. But let's review how to do it in its globality. The first thing that you have to do is to identify what needs to be optimized. It can be what the user wants you to optimize, or what you think has to be optimized. And inside that, you go to the code level and you say, okay, what is taking a lot of time? Also, what is taking small amounts of time, but all the time? You remember the millions of calls to one small procedure. It's extremely important. Then, that's where you start the process. And the process is one procedure at a time. And when I'm saying one procedure at a time, it's even worse than that. When you are trying to optimize one procedure, you're going to make one change, not 10 changes in a procedure. You're going to make one change that is supposed to make you go faster and test. Because sometimes what you think is going to make you faster is going to make your program slower. And if you code several modifications at the same time and don't check each of them, then you will not see that one modification gain is offset by another modification loss. So you have to do that one procedure at a time and one modification at a time, which means that the process can take weeks. If you don't do it that way, if you don't test each time each modification, you can spend weeks doing things and have absolutely no result. So optimization is an extremely tedious process, but if you do it well, you can have a result that is a 90% time reduction. I did. I worked on this, again, very big project. It was more than 600,000 lines of code. And at some point I would just stop coding, stop debugging, stop do all of that, and just work on optimization. And it could be for a month at a time I would work on optimization. And from the beginning of the month to the end, I could gain up to 90% of the time, which is huge. Suddenly the program that was so sluggish was working great. So it's a process that takes time in order to gain time. You have to accept that, and you have to accept that without an extremely strict methodology, you will not be able to have very big success in that domain. Now that you know everything about optimization, it's about time for an example. So in order to have a good example, I created a program that I call WD Slow. It's probably the worst program ever. First, because it's not doing anything useful at all, and second, because it's doing it very slowly on purpose in order for us to be able to do some optimization work on it. And of course, this project, this WinDev project, is available on the DVD you will or have already received. Let's have a look. So, here is a quick presentation of WD Slow, the worst program ever. As you can see, there's a series of buttons, and what I did here is, starting with that create slow button, I coded a small process. Doesn't do anything useful. It loops on company. It creates 10,000 companies, and for each company created, it creates a random number of contact linked records. The random being between 1 to 5. So as you can see, it's not really a real life process, but it was just to give you an example of what you can do on any type of process. Then I tried to optimize it, making one modification in this create less slow, optimize it even more in this one, that one, really, and finally this one. And what we are going to look at is each time the difference in the code and the result that I got. So let's look at the create slow. The process, of course, contains a display of information in order to see what we are doing. And I will just let it run for a few seconds to let you see what's going on. I will not let it go to the end because it's more than 30 seconds, and I'm sure that you have something more interesting to do than to watch name of a company for 30 seconds. So I'll stop after a few seconds and we'll look at the code. Okay, that's it. At the end of the process, there is a trace displaying the amount of time needed to do the process, and that's what I use to really see what see what's going on in each case. I could have used a profiler too, but in that case it would have been like using a cannon to kill a mosquito. There is really no point in there, so just storing the time and displaying it at the end. Now we are going to have a look at the code of this create slow.
And as you can see, it's not a very long code. So what do? First, declare time1 and time2 are as time. That's where we're going to store the elapsed time. Create the files empty, hcreation, contact, and company. As you can see, I'm forcing the creation empty of the file in order to be each time in the same status with an empty file. So there will be no difference induced by the fact that the index is becoming bigger and bigger. It's an extremely important step when you are doing optimization, is to put yourself in the same condition each time. If you're trying to optimize a process that is working on a file modification, you have to use the same files each time. Otherwise, you are introducing a variable that can completely change your result without your code modification being at all in cause. So it's really important to have a scientific-like methodology and to always be in the same condition. So here I'm storing the beginning time. As you can see at the end, I'm storing the end time and then just displaying the time difference in an info. The process by itself. Here, what are we doing? We are doing the company creation. As you can see here, we have the hadd, and before doing the hadd, we are putting in the company name and company city, company name plus the number of the company, and city plus the number of the turn in the loop. Then we are displaying this company here in this static, doing a multitask -1 in order for the company to be displayed and visible, and then for a random number between 1 to 5 we are creating the corresponding contact, and for that we are just constructing the name, the first name and the last name of the contact using the name of the company, and same thing for the zip of the contact. We are just using num2string of the company and so on, and then adding the contact, displaying the contact, and again a multitask. That's it. That's the process. So doing that, we had the following result: 3161. That's of course a result in hundreds of seconds, which means that it was 31 seconds and 61 hundredths. Of course, when you are going to test on your machine, you will have a different result. This result depends on the hardware that you're using, the version of Windows, the amount of memory, and so on. So that's another very important point. When you are working on optimization, the only way to have real comparison is to do the comparison on the same machine. And that's why when you are really in optimization mode, you should first test your original version on several hardware, one the slowest that you accept for your customers, and one the fastest, and then you should compare on each time on every machine. If you don't do that, you can make optimization that are going to make your program faster on a fast machine, but slower on a machine that is already slow. So it's extremely interesting to see that the difference that you get with one modification can be positive on one machine and negative on another one, just because the hardware is different. At that point, I started to try optimizing that code. So I duplicated the button and its content and made modification in it in order to try to be faster. That's the create less slow button. If you look at the code in it, you can see that it's basically the same thing, and there are a few comments here saying what I did compared to the previous test. It's extremely important to always document what kind of change you're doing from one to the next one when you are trying to optimize, because, well, if it doesn't work, you need to be able to come back, and sometimes it doesn't work. So what did I do in that test? I said, okay, multitask redraw is supposed to be faster than multitask. So here, when I display the company that was created, I replaced the multitask by a multitask redraw. But I did the same thing here after displaying the contact. But as I wanted to keep the same functionality, which means I wanted to still be able to cancel the process in the middle, I added these 3 lines where I use multitask -1 every 10 records. Okay? If modulo the index of the loop by 10 equals 0, then multitask -1. So every 10 record, I do a multitask -1. And for that, if I run it on my machine, once again, it will be extremely interesting for you to compare the result that you'll get. Well, for my machine, I got 28 seconds and 43 hundredths, which is about 10% less than the previous one. So I already have, just by using multitask and multitask redraw, I already have a better result. My first optimization cycle was good. I was able to gain 10% in that button. So at that point, I of course use that button as the source for the copy of that one. And here I made other changes. As you can see, now I have here just this transformation. Again, you see that I'm doing only one change at a time and testing. That is because, well, sometimes one thing that you think is going to gain you time is not going to. And if you do many changes at the same time, you will not know if something is in fact making you lose time in the middle of everything. So, I have my multitask redraw already in place. What do I do now? Well, in the previous code, I had this for ng index equal 1 to random the 1 to 5. Well, I told you that it's a good idea to remove any function from the inside of a loop if you can just get it once. That's exactly what I did there. Here I created an integer variable. Before the loop did this variable equal random of 1 to 5, and in the loop used the local variable instead. So in theory, we should have again a gain of time. Let's see what was the result. As you can see, 3265 compared to the previous iteration here, it's a plus 15%. It's an increase of time, which means that the modification that I did was not good. Why? We did everything by the book. Removed function from the loop, use a local variable, so it should be better. Well, yes, it should. If the random 1 to 5 function took a little more time, it would be. Obviously what happened there was that the fact to do the random one time, but take the result and copy it in Imax, this just taking the result and copying in Imax is longer than calling the random itself between 1 and 5 times. Why? Just because obviously the copy of the information in memory is much longer than the random function by itself. So this is not working. I have to go back to my previous code. That's why it has to be extremely well commented. Another thing that you have to realize is that it's perfectly possible that on your machine, this transformation that didn't work for me will gain time. It depends of your hardware, it depends of the memory you're using, it depends of so many factors. What I'm giving you here are the result on one particular machine. And that's another reason why you should always do this thing on several machines each time, because you will see that something will work on some machines, some on all machines, and some nowhere. And you will have to make the choice of what you want to do. The create really less slow obviously is going to start again from the create less slow, which is currently our fastest possibility. So if we look at what we have in that button, sorry, here we are. So I'm back to this ng index equal 1 to random 1 to 5. That's the previous stage. And then I did all that. What did I do? Created a variable which is a string, and in this did the num to string company ID company. Then in each of this line here, here and here, used the content of the comp string instead of doing each time a num to string company and ID company here, there and there. What was the result for that? 2848. So compared to that, it's the same thing. Yes, okay, it's 500 of a second slower, but remember that we're doing things random. So it means that one time it's going to be 500 slower, one time 1000 faster. At this stage, 500 of a second are not significant. So here, again, I tried to go faster by using a local variable and doing a less call of this function, and I don't go faster. So it's exactly the same problem than before. This modification doesn't gain me anything. Here I decided to try and no really to go a step further. So I kept the modification I had here and tried to improve on it. What did I do? Instead of just doing the num to string company ID company in the scomp, I also did the concatenation of the dash, which was done on the line after that. And then I added a contact string here, and in the loop I do the same thing. Contact is equal complete num to string ng index 4. Okay? So at that point in the lines I'm doing plus scomp plus scont, and here plus scont. Because I'm doing that, I'm having now the following result. 2814. As you can see, it's just slightly better than 2843. Compared to my original 3161, it's an 11% gain instead of a 10% gain. I'll take 1% more. It's not very good, so that's not an optimization that I really like, but it is an optimization on this machine at least. If on yours, it could be slowing down the process. So again, remember that it's not always the way you think it is at the beginning. At that point, I decided that it was time to stop trying to just modify the process itself, but try instead to modify the structure of the process to gain time. And remember what I was telling you about the no jigsaw rule? Well, that's exactly what I was doing in that code. I was, for each company, going to the contact file and coming back. So I decided to create the 10,000 company in a row, and then for each company to create the corresponding record. For that, I needed to store the company created in memory, and that's what I'm doing here. I'm using a memory zone, and in that memory zone, after each company creation, I am storing the information here. Then at the end of this loop, I am doing a second loop on the memory zone with the mem retrieve, and for each of them I'm doing what I was doing before with all the previous optimization, of course, and adding the contact. So that's at that point is not just modifying the content of my code, it's modifying the structure of my code in order to gain time. And here is the result. This is the create faster, 2710. This, compared to the original value, is 14% faster. So, by just changing the structure and going through memory, I was able to gain 3% more. And that's about the end of the optimization by itself. I wanted to show you what you could do. There are perhaps other things that you can do here to gain time. Now I'm going to show you a few things that you shouldn't do in the remaining of this example. And first, let's have a look at the denormalizing approach. In fact, what I did here in this create slower example button, I took the code that was here and tried to normalize it. Here's how. I saw that I was doing in these 2 lines, I was doing this exact same thing. So instead of doing it there, I just created an extremely small and fast code in which I would just do the concatenation of all this information and return it. And in these several places, I would just call the build ID procedure instead of doing it locally. So that is good coding practice. Put similar code in a procedure and code it from everywhere. That's what you were all told to do in all your software writing sessions. Well, the result of that is not that good when you're looking at it on the optimization standpoint. Here, the result was 3350. It's a 3% increase of time just because, compared to this, of course, just because I was using a normalized approach. That's not good. And that's the perfect example of what you can remove if you really need to gain time. Now I'm going to show you 2 other things that you should never do. I'm not going to give you the result. I'll let you play with that, and when you see the result you will not believe it. You've seen that in this window I have this field that is an image. It's a pretty image to make my UI so beautiful. And then I have this field that I'm using to display the information about the company and contact created. Now let me show you something that you should never do. You should never do this. Suddenly, this not only is bigger, but is overlapping the display field. What does that mean? It means that each time you are displaying something in this window and doing a multitask redraw, asking the window to do its job and redraw what has to be redrawn, now it does not only does it have to redraw the display field, but also the image that is under the display field. It has to. It's a see-through field, and you see the image. So each time it has to redraw that in order to remove the previous display and do the second one. And suddenly, each time, instead of having a standard gray color to write to remove the previous display, it has a graphic to manage, and this is much slower. Another thing that you should never do, and please try it also on your computer in this example, you do the same thing, but instead of just doing that, you really go over the top and you go in this field and you just decide that in the detail it is animated at creation, and you choose it as A. So you choose that and then you run the example. At that point you should also have a look at your processor usage. You will see that suddenly the processor is much more used. You will see that the display by itself is using lots of processing power, and that this is going even slower. Of course, that is depending a lot now on your graphical card's ability. If you have an extremely high-end graphical card with a processor doing the job for your main system, then the difference will be way less than it will be on a laptop with on the motherboard graphical card that is using mainly the main processor. So this will be very different from one machine to another. That's another test that you should do to see really what I'm talking about. So I'm going to put that back the way it was, and I will not give you the result. Let's just say that the result of that are plain ugly with the graphics. Now there is something else that you can do, and that will be the last thing we're talking about here. You've seen that I have this field for the display of my static, and it's a huge field that is using all the bottom of the window. If instead I'm taking that field and reducing it about that way, just enough to have the display of the company and contact information, and I just run the same create faster code, I get the following result. So without the graphics and reduced display zone, 1984. And suddenly I'm 37% faster than I was at the beginning. So all the difference in coding that I made to gain a maximum of 14% are to be compared to just changing the size of one field in the window and gaining this 14% plus 23%. Just reducing the size of the display field made a 23% difference. Takes me 3 seconds. Took me hours to go through all the loops to gain this 14%. I think that this is a very good demonstration that very often optimization is not where you think it's going to be. This optimization course comes to a conclusion, and for this conclusion I would just like to remind you of a few very important things. The first thing is that there is no strict rule. As you can see in the examples I gave you here, I tried to optimize in several ways, and several of them didn't work, even though in theory they should have given me a gain in processing. So if you think that you're going to be able to mechanically gain time by changing this, changing that, just forget about it. It's not working that way. It's even worse when you really try to optimize the right way, and by that I mean on with tests on different hardware. You of course can try to do that on virtual machines with different operating system on the same machine, but that's not real optimization. I'm talking about real life, having an old machine, a more recent machine, a very recent one, another very recent one with different hardware, and testing on all of them for each modification. So creating the executable, not doing the test in test mode. You have to realize that when you're working on a big project and you do this kind of modification, it can be each time 15 minutes of compiling. So you make a modification of 3 lines, then you compile 15 minutes. You copy the project on 4 different machines and you test each time on 4 different machines. And sometimes you have to back up and restore a database in order to start always on the same thing. So just one test on one small optimization can be a 2-3 hours process. So there's no strict rule. You have to realize that. You will have to test, and you will have to test on your hardware and several others. Remember also that the results of that could change from one version of WinDev to the next. You do not know what the pieces of developers are coding behind the scene. It's perfectly possible that in order to solve a bug, they have to increase the time that a function needs to work. Or that because they are doing things differently, suddenly one function is going much faster than before. You have absolutely no control on that. So the only thing you can do is optimize now and live with it. And then if one day your program is too slow in one thing or another, with the current version you'll have to optimize again. You also have to realize that sometimes the only available optimization is to remove a functionality, either temporary or definitely. If one functionality is just taking too much processing power, perhaps the only thing that you can do to have your program work in a usable way is to remove this functionality and to accept that you won't have that functionality. It's sometimes the harder choice to make, but it's also sometimes the only available one. It doesn't mean that you will not be able to add that functionality in 2 years when the hardware is powerful enough for what you want to do. But sometimes, if you want to go too far away now, you just won't have a program that is usable. And because of all that, you have to realize that optimization is as much an art than a science.